Everyone. So today we're starting talking about angles formed by parallel lines. And you actually have notes in your notes packet on this, but I made sort of a last minute change last night and decided I like these notes better. So you should now have this handout in front of you. Okay? These are notes. Okay? So I know they're not included in your notes packet. If you want to take your notes packet apart and insert them, you can. If you'd rather just keep them separate, that's fine too. But these are going to be your notes for this section instead of the ones that are in your packet. The ones in your packet, we might do some pieces of them tomorrow when we're back together, but really this is going to be what you need. So, talking about parallel lines, there's some vocabulary we need to know here. The first one is transversal, okay? Transverse, by the way, means to cross. So a transversal is a line that crosses two or more other lines. Okay, so you should be filling this in with me. Okay, a line that crosses two or more lines. So in this example, this picture that's drawn here, this line T, see how it goes across lines M and N? This is the transversal, line T, okay? And honestly, in this type of situation, we don't typically care about transversals, but transversals get to be important when these two lines that it's crossing are parallel. So if these two lines are parallel here, then the transversal becomes very important. Okay, sort of similar to that, corresponding angles. Corresponding in math almost always means like in the same position or the same type. Okay, so corresponding angles are angles in the same position in regards to the transversal. Okay, so for example, angle 1 here is to the left of the transversal and it's above the line, okay? So the corresponding angle to that would be angle 5 because angle 5 is to the left of the transversal and it's above line N. So these two lines are in the same position in regards to the transversal and the other lines, okay? Similarly, angle 2 and angle 6 would be corresponding. 4 and 8 are corresponding, and 3 and 7 are corresponding. Again, in this situation, corresponding angles actually are not all that important, okay? But when they do get important is when these lines are parallel, and you're going to see that down here in the corresponding angles postulate. So sort of before we look at that postulate, here's what I want you to see. I've got the same situation over here, but I've got my lines parallel, okay? And maybe sketch this out, all right? And those little arrow lines, by the way, that's a marking that shows that those lines are parallel. Remember, they're only parallel if I mark them and tell you that they're parallel. Okay, so let's say that this is angle 1 and this is angle 2. Those are corresponding angles. Well, if these lines are parallel, that means they're going in the same direction. So they're both intersecting this transversal at the same angle. Okay, because if they're sloped the same way, meaning they're parallel, they're going to both intersect this transversal at the same angle. That means angle 1 and angle 2 have to be the same. They have to be congruent to each other. Okay, and that's what's called the corresponding angles postulate. So, if two corresponding angles have the same measure, actually, what we just talked about was part B. Let's do part B first. If we know for sure that the lines are parallel, okay, then the corresponding angles are congruent. Okay, that's going to be a really important thing for us to be using. So if the lines are parallel, then corresponding angles have to be congruent, meaning they have the same measure. What I want you to look at is part A. If they have the same measure, then what do we know? The truth is, the corresponding angles postulate is actually a biconditional. This is an if and only if, meaning that the converse of this is true. This statement A is the converse of statement B. So if two corresponding angles have the same measure, then we know the lines are parallel. This is going to be important when we start talking proofs. That, by the way, is symbol for parallel. Okay, so if we know the angles are congruent, then the lines are parallel. And if we know the lines are parallel, then the angles are congruent. Okay, it's a biconditional. The converse is also true. So looking at this example here, okay, remember these markings mean we know those lines are parallel. So if we know those lines are parallel, we know that angle 1 is congruent to angle 5. Angle 2 would be congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Okay, so that's what the corresponding angles postulate is all about. Remember, a postulate is something that is assumed to be true. It's sort of common sense. And again, it is sort of common sense that if these lines are passing through the transversal at the same angle, that the angles formed by them are going to be the same. Okay, so that's what corresponding angles is all about. Let's flip to the back of that page. You should have a page that looks like this. Proofs by transitivity. Okay. So, some more vocabulary to throw at you that kind of goes along with the corresponding angles and things like that. We're going to start talking about interior angles and exterior angles, and you're going to be seeing this picture right here a whole lot. Okay? So, I want you to picture these parallel lines. Imagine they're like a hallway. Okay, so this is like a hallway of a school. The interior are the angles on the inside of the hallway, and the exterior are on the outside. Okay, so all of the angles in the hallway are interior. So 3, 4, 5, and 6 are all interior angles. Exterior are the ones on the outside of the hallway. So 1, 2, 7, and 8 are exterior. All right. Now we're going to take some of those and pair them up. So AIA, and you're going to see me use this abbreviation a lot. What that stands for is alternate interior angles. Okay. And what that means, alternate means opposite sides of the transversal. And interior, just like we talked about before, means inside the parallel lines. Okay, so these are pairs of angles that are on alternating sides, okay, in alternating positions, and they're between the parallel lines. So from my example up here, the alternate interior angles would be angle 3 and angle 6. That's one pair of alternate interior angles. Think for a second about what the other pair would be, because there's another pair that go together. You're thinking 4 and 5. Angle 4 and angle 5 are alternate interior angles. So all 4 of these, if you look, those are your interior angles, okay? But alternate interior means kind of in that zigzag. So, and you're going to see me do this a lot too. If you sort of highlight those lines. Do you see the zigzag there? And I'm kind of highlighting the 3 and the 6. Okay, and then I could also zigzag the other way and highlight the 4 and the 5. So the zigzag angles, those are alternate interior angles. So AEA, very similar, is alternate exterior angles. Only difference here, by the way, alternate still means opposite sides of the transversal. Exterior now means outside of the transversal, but you're still going to have that kind of you know, one here and one here kind of thing. So looking at this picture, the exterior angles are the ones up here and the ones down here. So my alternate exterior would be like 1 and 8. And then my other ones would be like 2 and 7. Okay, so that's how they pair up when I'm looking for alternate exterior angles. Okay, so there's this and there's this and this. That's alternate exterior angles. Okay, switching gears a little bit. So we've talked about all these different types of angles. All of these angles are going to be really important down the road, okay? But they can't be really important to me until I can do a proof with them, all right? And so we're gonna write our first proof here in a minute. It's going to be sort of an informal proof, okay? But before we can do that, we need to know what something called the transitive property is. Now, we talked about proof by transitivity. Don't write this part down, but I just want to remind you that proof by transitivity is when we said if P implies Q and Q implies R, then I could take those together and make one big statement, P implies Q implies R, and then drop out the middleman and say P implies R, okay? This was the law of transitivity that we did. Transitive property is really similar to that. The transitive property says if two things are equal, so if A equals B, and then B is equal to C, then we know that A would have to equal C. Okay? Because if A is the same as B and B is the same as C, then A and C have to be the same also. That's what the transitive property does. And transitive property always has this feeling of like, well, if this equals this and this equals this, then these two at the beginning and end are equal. Okay, so we are about to prove something, and it doesn't say proof, but that's really what we're doing. It says, why are alternate interior angles congruent? Okay, so just to remind you, for example, angle 3 and angle 6 are alternate interior angles. And if you haven't picked up on it yet, those angles are going to have the same measure. But that's not quite as common sensey as like the corresponding angles postulate was. Okay, so we need to actually say why. So, for example, I do know by the corresponding angles postulate that angle 3 would have to be congruent to what? So I'm thinking corresponding angles, not alternate interior, but corresponding. 3 would have to be equal to what? You see how 3 and 7 are in the same position? Angle 3 would have to be congruent to angle 7 because of the corresponding angles postulate. And I'm allowed to use that postulate because remember, a postulate is like common sense. We're all going to assume it's true. So I now know that angle 3 is congruent to angle 7. Okay? Well, how are angle 7 and angle 6 related? Angle 7 and angle 6 are vertical angles. We talked about this yesterday. So angle 7 has to be equal to angle 6 because of what's called the vertical angle theorem. And I'm not sure if we listed that as a theorem yesterday. That stands for vertical angle theorem, all right? Which means that because these are vertical angles, they have to be congruent. Well, now look at what we have. We have, and I'm going to write this off to the side, I have that angle 3 is equal to angle 7, whoops, and angle 7 is equal to angle 6. So now what do I know? Now I know that angle 3 must be congruent to angle 6 because of the transitive property. That was that hopping from one to the other. And look at what I just did. Angle 3 and angle 6, those are alternate interior angles. So I just showed that my alternate interior angles always have to be congruent. Okay, that's what this process looks like. Is you start with something you know has to be true. Okay, I know that these angles have to be congruent because they're corresponding. And we just talked about why corresponding angles are congruent. We also already know that vertical angles are congruent. By the way, I could have made you prove this yesterday. I didn't, but it has been proven. So as long as it's been proven, I'm allowed to use it. And now I can use the transitive property to kind of link these two things together and say, look, these two have to be equal. I could use the exact same process to show that 4 and 5 have to be equal. Okay? I could say 4 is congruent to 8 because they're corresponding, and 8 is congruent to 5 because they're vertical, so 4 is congruent to 5. Okay? Could do the same thing with the exterior angles. Okay? 1 is congruent to 5 because they're corresponding. 5 is congruent to 8 because they're vertical, so 1 and 8 have to be congruent. So this same process shows that alternate interior angles and alternate exterior angles are always congruent. That's a really big thing to pick up on. In fact, I'm going to go back up here and list that these are always congruent to each other. And that these, well, I kind of don't really need that, but these are also always congruent to each other. Sorry, that got to be kind of a mess. Okay? Really, really, really important for you to know there. All right, let's try some examples. You should have some examples in front of you. Okay? So first up, if angle 1 is equal to 105, we're going to find all the other missing angles. And this is actually really easy because there's only 2 angle measurements in this whole diagram. So if angle 1 is 105, do you see that angle 5 is corresponding with angle 1? So I know right away that angle 5 is 105. I'm going to put that over here, 105. Okay? Also, angle 1 and angle 4 are vertical. And we talked yesterday about how vertical angles are always congruent. So angle 4 is 105. And then angle 8 is corresponding with angle 4. It's also vertical with angle 5. So either way you go, angle 8 has to be 105. But now the tough part is, how do I get those other angles? Not really the tough part, but that's the next piece. So this kind of goes back to what we were doing yesterday. Okay, and yesterday we said if this angle is 105, how do I get this angle? Well, you should see that they make a straight line. So to get this angle, I can do 180 minus 105, and I get 75 degrees. That means that angle 2 is 75 degrees. Okay. That also means that angle 3 would be 75 because it's vertical with angle 2. Angle 6 would be 75 because it's corresponding with angle 2. And angle 7 would be 75 because it's vertical with 6 and corresponding with 3. So all of these other ones are going to be 75 degrees. Okay? So I should be able to throw any angle measurement on there for you, and you could take it and run with it and fill in every other one. Okay? All right, let's take a look at example 2. Okay? We've got P is parallel to Q, and it's giving me information about angle 5 and angle 2. So before I even worry about this, I want to find where angle 5 and angle 2 are. And what I want you to think about is, what is the relationship between angle 5 and angle 2? Okay, do you see the zigzag? Okay, angle 5 and angle 2 are alternate interior angles. So that means angle 5 is equal to angle 2. So I know this has to equal this. So I'm going to say 5j minus 27 has to equal 3j plus 5. And from there, I'm just going to solve. So let's subtract 3j, end up with 2j minus 27 equals 5. Let's add 27 to both sides. And I get 2j equals 32. Divide by 2, and I end up with j equal to 16. Okay. But now it wants me to go back and find angle 1. Angle 1, I don't know anything about angle 1. Well, angle 1 is vertical with angle 5, so 1 and 5 have to be the same. I just found j, So I can go up and figure out what angle 5 is. For angle 5, it would be 5 times 16 minus 27. Let's see, this is going to be 80. 5 times 16 is 80, and 80 minus 27 is 53. So that means angle 5 is 53 degrees, which means angle 1 is 53 degrees. Now, let's see. Angle 3, this is a little bit different. Angle 3 is not 53 degrees. It does not match angle 5. But angle 2 is 53. And then you should be able to see that angles 2 and 3 make a straight line. Okay, so I can do 180 minus 53, and I get 127. And then angle 4 is also going to be 127 because that's an alternate exterior angle. Okay, so that's 127 as well. Okay, so again, once you have one angle measure, I could ask you to fill in all of these if I wanted to, but really it's just either they're going to be this number or it's going to be 180 minus that number. Okay. Now, it wants me to explain why angle 2 is congruent to angle 7 without just saying, oh, they're alternate exterior, I know they're congruent. Because we haven't technically proven that yet. I mean, we kind of talked about it, but we haven't proven it. So let's start with something we do know. I'm going to start with this angle 2. And I'm going to say something that angle 2 must be equal to. Well, angle 2 must be equal to angle 6 because they're corresponding angles. And you have to say why these things are true. Okay, that's a big part of your explanation. It's not enough just to list it. So because of the corresponding angles postulate, I know 2 and 6 are equal. Okay? Well, 6 is congruent to 7. Again, think about why. Because they're vertical angles. So vertical angle theorem tells me 6 and 7 have to be equal. And then if I put those two things together, 2 is equal to 6, 6 is equal to 7. Therefore, 2 is equal to 7. Whoops, 7. Sorry, that doesn't mean to look like a Z. Because of that transitivity property. If 2 is equal to 6 and 6 is equal to 7, then 2 is equal to 7. Okay? Okay, that's it for now. Homework tonight is a worksheet that looks very similar to what we just did. It says Lesson 5-4 homework at the top. You'll be handed that out in just a second. Make sure you refer back to these notes because the notes line up with the homework very, very well. Okay? And we will go over this tomorrow and we'll spend another day looking at these different angle pairs.